Hi guys, Stuart from Solidtec. Just wanted to show you a little bit about forming an internal corner and mitering a corner on a piece of sheet metal. Got a few options as to how we might go about that. First one I'll show you is just using an edge flange. So if we go into an edge flange and say we want to use a couple of edges, so like a flange going along here and along this edge, normally I'll just put use the default bend radius on this material, and I'll just say something like 40 millimeters for our flange. Now, if we go okay to that, we get our flange formed, but when we try and flatten that, we're going to get intersection of material, so it's not actually going to work properly. So we need to remove some of that material. If we measure the length along that edge, I can see down the bottom that's 37 millimeters, so one option we've got is to put a break corner in there. We can give it a distance close to that length of flange, so I'm going to say 36.99. Get it pretty close, and we can go okay, and then you'll notice that when we flatten that out, we got a gap in there. Now you might have to play around a little bit with your edge flange details. If I edit that feature, if my gap is too small in here, we might still get an overlap. Okay, so if I just go okay, it looks alright at this stage, but when we flatten, you might actually find that it's intersecting. That one still looks okay, but just be aware that that gap is going to have an influence, and you can see it here a little bit, that it doesn't look very, very good because of the corners in there overlapping a little bit. So I'd be better off leaving that edge flange with a slightly larger gap. So I'll leave it at 4 millimeters, and then we can see down in the corner that looks fine. So that's one method we can use to achieve that result. Okay, another method we might like to use is by doing a miter flange. So I'm just going to reload that same part, and we'll look at it from a miter flange point of view. Miter flange needs a sketch, so if I start just sketching on that top surface, I'll just sketch a line off that corner, and we'll go along and just make sure that's a vertical line. Now, just putting a dimension on that, so I want to go from this edge here over to here, so we've got our same 40 millimeters. Okay, very similar starting point, and then we can go into our sheet metal and say let's have a miter flange that runs it out along that edge and along that second edge, so we get our two. I'll put the gap same as we did before, 4 millimeters, bending inside the material. Seems alright using the default bend radius once again. So same sort of result as you can see, but once again when we flatten that, we get an overlap in material, so it's not physically possible to get that right into the corner. We can do the same thing again. We can do a break corner on that edge, just go along same sort of position, and we'll go okay. There we go. So maximum value in this case is going to be 35. That's because of the material thickness. So I'll just change that, 35. It's good that it tells us what we need. And now when we flatten that out, now we've got a gap in there as well. Okay, so a couple of techniques, two different edge flanges, but similar methods in that you need to clear away the resultant material. I'm going to reload that one more time because there is another option that you could choose. Okay, and that is go to your edge flange, build your edge flange in the same sort of fashion that we did before. Go in, I'll leave the gap the same, I'll leave the size pretty much the same, but in this case we can actually go in and edit that flange profile, because this is the sketch that controls the shape of that geometry that we're going to put in there. So you can see at the moment we've got a straight line coming off the edge there because of this vertical relationship. So if I just delete that relationship, it gives me the ability to sort of move that flange. We can also move it a little bit off the edge to make sure we've got some clearance. And if we just put a dimension on there, so let's just go to dimension and give it a dimension from that inside edge. I'm just going to give that 2 millimeters of clearance. I'll put our angle in here because we want a 45-degree miter. And one thing that might be useful just to specify that overall length once again. So it was our 40 millimeters, gives our distance. Now that's fine for the first flange, but we haven't done anything for the second flange. So again, we can select that flange, edit the profile, go back to that edge, just delete that relationship. We can move that edge, we can move it a little bit off the edge like I did on the other one, and once again I'll just go into dimension and say what's the distance from that point to there and there. Let's just go for our 2 millimeters, or same measurement for our angle, 45 degrees, and distance to the top of the flange, I'll stick those all to be the same, 40 millimeters. Okay, so now if we go finish, we get those flanges in there. They've automatically got the geometry we wanted. A little bit bigger gap in that situation. but you can see the principle is the same sort of thing, but that one, it just required one feature. Now, you decide which one's going to be appropriate for you based on how much modification you want to do on those individual sketches, or whether you want to use a different feature to achieve that. Hope that gives you some insight into putting some mitered flanges on an internal corner in sheet metal. Hope that's useful for you. All the best.